Hi everyone, my name is Fernando and today I will present you single input and single output control strategies for drone, a comparison between model-based control and model-free control. I will briefly show you three simulations of SISO control strategies applied to an iris drone that is a multivariable dynamical system. To do that, I will use the attitude control from PX4 firmware to input translation speed commands and control the drone's position in X, Y, and Z direction. Now you can see the model-based control simulation, and as a complementary tools I am using Python, Rust, Robotic Operating System, and Gazebo simulator. Next, some graphs will be presented where the orange line is the reference, the blue one is the real trajectory, and the gray range is the tolerance. The XY plane, the coordinate by time, and the control effort are presented. Now the model-free control strategy is presented. Note, in this detailed portion of the simulation, that the drone movement is not smooth using the model-free control. In this strategy, we use an ultra-local model to obtain it, of course, online during the drone's operation, and we use it to eliminate some non-linearities and coupling effects. So the main idea is enhance the SISO capability to handle with multivariable system like a drone. The FIR function presented in the control effort graph is responsible to eliminate these non-linearities and coupling effects. Next, some graphs will be presented where the orange line is the reference, the blue one is the real trajectory, and the gray range is the tolerance. The XY plane, the coordinate by time, and the control effort are presented. Note here that the maximum peak is much bigger than the 3% specified. In the control effort graph, you can see that phi is a piecewise function, and because that control effort is a piecewise function, and it's not smoothly enough to the drone, and because that the maximum peak was enhanced. Finally, we are showing the model-free FIR control. The FIR in the name is because we added a moving average to turns phi smooth, and with this we have the advantage of eliminating or reducing the non-linearities and coupling effects, and by the same time we have a smooth control effort that guarantees the desired maximum peak specifications. The XY plane, the coordinate by time, and the control effort are presented. You can see that with the FIR modification, the maximum peak was reduced and the phi function becomes smooth, and the phi function is no more piecewise function as in the model-free without FIR modification. Finally, I would like to end this video showing you a beautiful drones view of our university, the University of São Paulo. And if you liked this video, give it a thumbs up and subscribe to our channel. Feel free to comment below, and if you want to go deeper into this content, check out our paper whose link will be in the video description. I hope you enjoy it and see you next time.